Welcome back, everyone. We're continuing our discussion on the fifth programming assignment and just talking about the different classes and how they fit together and looking at some source code. Obviously, I haven't written all the source code for you, but I've given you enough to get you going here. So in the last video, we talked about the customer and the account, those two classes in particular. So now we're going to get into these ones below, the savings, checking, money market, and this interface, iTaxable. So let's start with the checking account. Notice that it inherits directly from account, or in Java parlance, we would say that checking extends account. Now, what that basically means is that a checking account is going to inherit all of the characteristics of its parent. So a checking account will have a constructor named checking, which takes a string and a double. Incidentally, a constructor is not inherited. Constructors do not extend one another, so they're independent. The checking account constructor is its own entity. But the checking account does pick up deposit, withdraw, toString, balance, and account number. All of those things belong to the checking account because they're inherited from its parent. In addition to those, all of that stuff, you're adding on a cash check method, and you're also overriding the toString method. You're overriding this one right here because this is the base or the parent class's toString. So there isn't a whole lot of anything new in the checking class, just a couple of additional capabilities. So let's go ahead and take a look at the checking account class in IntelliJ. So here's my project, and right here is the class named checking. It extends account. And if I open it up and look at it, this is all there is to it. Here's my constructor. It takes an account number and a double for the amount. And notice all I'm doing here is I'm handing the data off to my parent. In other words, I'm calling super, and super basically says call your parent's constructor and pass in these two things. Now, the account class, if I just hover over that a second, if you look at lines 151 to 155, you'll notice there that I need a string and a double to satisfy that constructor. So coming back to checking, which is its child, it likewise passes a string and a double into its parent's constructor. Again, this does not happen implicitly. This is an explicit call. Constructors do not extend one another implicitly. Now, going back again to that constructor, you'll notice that it throws exceptions. And that's because deposit is capable of throwing exceptions. And the reason for that is if you pass in an amount that's not valid, you want that exception to be thrown. So even here in a checking account, if you pass in a negative amount for your opening balance, that's invalid. So when I call super and pass these two values in, and then super is going to call deposit, deposit's going to see that negative number and throw an exception. And that's going to bubble up the call stack through this method because this throws the exception up to whoever called it. So the exception bubbles up. Basically what happens is deposit throws a new exception on line 161. That gets handed to the constructor on 151, which doesn't have a try-catch block. So the method in 151 throws the exception up to the checking account constructor on line 204. This method doesn't handle exceptions either. There's no try-catch block here, so it passes the buck up the chain. And this would ultimately go to the main method of the bank class, which we haven't talked about yet. So the bottom line is somebody needs to handle the exception, and that's usually done at the actual application proper, what the user interacts with up at the high end, and that's originates out of the main method of the program. So like the constructor, we have our cash check method. We take a check number and an amount, and we're withdrawing. Now this again could throw an exception, so we pass it up the call stack. And then we have our toString method, you'll notice here that we return a string of format CHK followed by a tab and then a string which gets set to super.toString. So whatever the account's toString method gives, which if you look here, I guess I can't see it. I'm going to have to expand this out. This is the account class's toString method, line 196. So this is going to get called as a result of this block of code right here. This, whatever this returns back, gets plugged right into this %s substitution parameter, and then the string is going to be chk tab and then whatever that is. And that's what's going to get returned. So when you ask a checking account to describe itself, that's what it's going to do. Again, we're taking advantage of inheritance to avoid some duplication of code. So that's the checking account. Well, what about the savings account? The savings account is a little bit more complicated. It, first of all, can be taxed by the government. And so what we're doing is we're saying any entity that is taxable, we need to find out what the taxes due for that entity would be. So since savings is taxable, we want to make sure that taxes due is implemented in that class. And the easiest way to enforce that is to create an interface. An interface is like a contract. Whatever you put inside of the interface must be implemented in whoever implements it. So for instance, if savings implements iTaxable, savings must create a taxes due method that returns a double. If any other class out here were to be created and implement iTaxable, it too would have to have a taxes due method created and implemented. So if I just look at the interface itself, interface iTaxable, the only thing in it is double, get taxes due, open and close, parenthesis with a semicolon. Notice there's no implementation in this declaration. It's basically saying, look, if you want to implement interface iTaxable, you're going to have to make one of these. And that's really all there is to it. So bearing that in mind, if I go down to my savings account class, here it is right here. It's a class. Its name is savings. It extends account, and it implements iTaxable. There's a difference between extends and implements. You extend classes. You implement interfaces. And if I implement iTaxable, that means somewhere in my class I'm going to have to provide a get taxes due method. And I do that here on line 254. Now I, at this point, return a 0. Actually, there should be code in there that actually gives you valid values, but for now I've at least got it there and it's ready to go. Notice the annotation of override here. This may seem confusing because what are you actually overriding? This is the first time we're seeing get taxes due on this class inheritance chain. Well, because the interface declares the method get taxes due, the annotation to override is referring to the interface declaration. And it is possible to partially implement the method sometimes in an interface. Therefore, you override a partial implementation. Now, we're not going to get that advanced in this course. So, for our purposes, the override is usually used when you extend another class and you want to supersede a parent's method with your own as a child. But in this case, we're implementing what's required of us in an interface. So override doesn't really make sense here or fit as well here. However, the compiler does use it because it's customary anytime you extend or implement and you provide a method that's already been defined or implemented prior with this override parameter. So we have our get taxes due. And then we have our toString method, and like the checking account, it returns the same nomenclature except it uses an SAV instead of a CHK. Other than that, the code is exactly the same. What's interesting about the savings account is it has an annual percentage rate that is declared static. And that's because every savings account that you build for this bank would have the same APR. If you change the APR for one object, you'd want to change it for them all. So it's like a global variable, but yet it's restricted to the class that it's defined in. So it's a static double. Therefore, the getter and setter for it, which you see on line 229 and 234, are both declared static. The setter throws an exception because it validates the APR. If it's less than 0, it throws an exception. Otherwise, it sets it directly into the class. Notice the use of the word savings dot annual percentage rate. That's because annual percentage rate is not a field. When you have a static variable inside of a class, it's not a field. A field is for an object. This is a static variable that belongs to a class. Okay, so next thing we have the add interest method. It takes the current date, and whatever month you're in, it gets the length of the month, or the number of days in that month. So that's what line 248 is doing. Then it takes the annual percentage rate, divides it by the number of days in the year, then it divides that by 100 to get the percentage into a rate. Then it multiplies that by the number of days in the month to get the monthly interest percentage, multiplies that by the balance to determine how much interest you've earned for the month, and then deposits that amount of interest into the bank account. So that's basically the savings account. The money market account is a special type of savings account, so it extends savings. So let's take a look at this money market account here. Notice it extends from savings, and the only real difference is that it has a minimum balance field. And because of that minimum balance field, we need a getter and a setter for it. We have a constructor that takes a string and a double, and that's the standard constructor that checking takes and savings takes, where you pass in your account number and your opening balance. And then we have our withdrawal method. Now, why do we have a withdrawal method here when we already have it in our parent's parent, way up here in account? We have a withdrawal. We are overriding the withdrawal in the money market because we don't want the user to withdraw money if it takes them under their minimum balance. Now, the withdrawal method up in account up here, he is written so that you can't take out more money than what's in your account. In other words, you can't overdraw your account. But we have to we still want that enforced, but actually we want to supersede that with a different rule that says, no, not only do you not want to overdraw the account, but you actually don't want to take money out if you fall below your minimum balance. So it's even more stringent than the account withdrawal method. So what that basically means then, if you look at the money market account, first of all, we have a minimum balance, and notice that it's a static variable, because every money market account will share the same minimum balance. You don't want two money market accounts with different minimums. The minimum balance is a policy from the bank, and you want every account that's a money market account to have the same balance, minimum balance. So we make it static. And in our getter and setter, those are also static. The setter throws an exception because if the minimum balance is less than 0, we throw an exception. Otherwise, we set the minimum balance. Notice we use the class dot variable name because it is not a field, it's a static variable. Now check out the withdrawal method. Notice we're overriding, and we are looking at our current balance, and we're saying if you were to withdraw the amount passed in, okay, so if you were to subtract that off the balance, would whatever you have left be greater than the minimum balance? If that's true, then I'll proceed with the withdrawal. Whatever money I have left in the account after that point would be at or above the minimum balance, but it would never be under that. What I didn't do here, and what I really should do as I'm thinking about this, is if the withdrawal would result in you going under the balance, minimum balance, I should throw an exception that says this withdrawal would drop balance below minimum required, or something to that effect. So if I throw that exception, it will cover me that way. So that's what my withdrawal is doing. Other than that, let's see. My constructor takes the usual account number and balance. This here, I'm calling super to set things up in the child or the parent class. Now right here, if balance is less than minimum, throw a new exception. Can I call the withdrawal method instead of doing this? I don't think so, because this is a little bit more specific in terms of the name of the exception. And at this point, I'm not subtracting anything. I'm just looking at the balance and saying, look, if you're less than the minimum, we can't accept you as an opening balance. So we throw an exception saying, no, your balance is not sufficiently high. A couple different ways you could handle that, but that's how I set that one up. Another caveat on this one, the toString method, in this particular case, I do not go back to my base class to get the stock toString method from that. And that's because here I put MMA, then I tab it out, put a pound sign, put my account number, and then a %2F with my balance. Now, if I look at the savings account toString method, it puts SAV tab and then it calls the accounts toString method, which returns the account number, a tab, and then the balance. I'm looking at this and I'm not seeing a difference here. It looks like I should be able to just do something like this. Just like I did with savings and checking. With money market, I put MMA, a tab, and then my string, which I pull from super.toString. Oh, I see my issue. If I do that, it's going to put MMA, tab, and then it's going to call the super toString, which is the savings account, and his toString is going to put an SAV there. So I'm going to end up with MMA, tab, SAV, and so forth. That's why I broke that out separately. Well, a couple ways you could handle that. I could let it put the MMA and the SAV in, or I could replace SAV with nothing. And return the string. That way, it would put MMA, tab, SAV, but I would just replace the SAV with an empty string, and that way I could get rid of the SAV. So that is a little extra thing I would have to do, and that would enable me to avoid duplicating code. I think that would be a little bit better approach than to reinvent the wheel on the end of that string, creating that balance. Okay, that leaves us then with the actual bank account, or I should say bank class itself, which is up here. So up in this section, I'm creating a scanner. I've got my static customer. I've always got one customer that's current, so I make that static. And then in my main method, I have a do loop with a while. This is an infinite loop. Notice the true condition on the while. Inside of it, I have a try-catch block. I present my menu. I get the choice. I have a switch statement on it. If they choose the third option, I do a system.exit0, which exits them out of the program. That enables me to do this while loop. If they choose case 1, I call create customer, which is a static method inside of this class. 2 is view customer, and if you look at those two methods, view customer simply asks for the customer number. It loads the customer from the file. Okay, it loads the customer from the file. This customer's name is C, and then it calls c.getCustomerDetails. If I want to create a customer, I get all the information. I new up the customer, call it C. I ask if they want a checking account. If they say yes, then I ask for the balance. I had to change that to CUST so it wouldn't conflict with my checking account. Okay, so in Create Customer, I new up a customer with the name and number. If they want a checking account, I get the balance. I new up a checking account and I add it to the customer. If they want a savings account, I get the data, new up a savings account, and then I add the account to the customer. If they want a money market account, I get the APR, set it as a static variable here, get the minimum balance, telling them what it currently is, so they know that. Then I'm asking them for a balance, getting that, creating a money market account, and then I'm adding money market account to the customer. Then once it's all said and done, I'm taking the customer class, calling the save customer method, passing the customer to it, and that effectively saves the customer into the file. And then I just print out the customer details after it's been saved. So the key here when you create a customer is you new it up, you add accounts to it, and then you save it to your file and then print out the details. When you want to view a customer, you enter the customer number, you load the customer from a file like this, give it a name, CUST I call it, and then print out the customer details for that customer. And if you do it that way, you will not need a static customer at the top. This basically, you're going to have a scanner up here, then your main method, and you're going to create customers, view customers. And both of those procedures, I can't quite fit them both, but here's my view customer and here's my create customer. So you can see them both here doing their job. So that in a nutshell is this assignment, and there's a lot of things that you're having to do here, but the big takeaway from this is getting the file I/O taken care of, and then implementing the try-catch blocks, the try-catch block in the main method, and then throwing all the exceptions at the various points in the program. So I hope you find this helpful. I'm going to close off the series at this point. And as always, if you have any questions, let me know. And thanks for watching.